Hello viewers, welcome to our channel Career Prep. Clock is one of the most important topics for government sector entrance exams like UPSC, SBI PO and Clerk, IBPS PO and Clerk, RRB PO and Clerk, SSC, etc. In this video, we'll solve a few problems on faulty clocks. Questions are dealt with in this video along with clear explanations to make you understand the concept clearly. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Let's now look at the types of problems asked in competitive exams on faulty clocks. Type 1. Finding the time shown by the faulty clock. Type 2. Finding the actual or true time. Type 3. Finding at what time the faulty clock shows the correct time. Type 4. Finding the time gained or lost by the clock when time interval of coincidence of the hands of the clock is given. Let's now solve a few problems of each type. A clock gains 5 minutes in 1 hour and was set right at 8 a.m. What time will it show at 8 p.m. on the same day? Here you are given 4 options and you have to find out which of these options is the correct one. So here it's given that the clock was set right at 8 a.m. and you have to find the time the faulty clock will show at 8 p.m. on the same day. So total time from 8 a.m. to 8 p.m. on the same day would be 12 hours. Now it's given that in 1 hour the clock gains 5 minutes. So in 12 hours it gains 12 multiplied by 5, which is 60 minutes. Now 60 minutes is nothing but 1 hour. So the clock gains 1 hour in 12 hours. Now since the clock is gaining time, you have to add 1 hour to 8 p.m. to get the time shown by the faulty clock at 8 p.m. So the time shown by the faulty clock at 8 p.m. on the same day would be 8 p.m. plus 1 hour, which is 9 p.m. So the correct answer is option A, 9 p.m. A watch loses 5 seconds in 1 hour and was set right at 7 a.m. What time will it show at 2 p.m. on the same day? Here you are given 4 options and you have to find out which of these options is the correct one. So here it's given that the watch was set right at 7 a.m. and we have to find the time shown by the faulty watch at 2 p.m. on the same day. So total time from 7 a.m. to 2 p.m. on the same day is 7 hours. Now it's given that in 1 hour the watch loses 5 seconds. So in 7 hours it loses 7 multiplied by 5, that is 35 seconds. Now since the watch is losing time, you have to subtract 35 seconds from 2 p.m. to get the time shown by the faulty watch at 2 p.m. So the time shown by the faulty watch at 2 p.m. on the same day would be 2 p.m. minus 35 seconds. Now 2 p.m. is nothing but 1 hour 60 minutes. Now if you take out 1 minute from 60 minutes, you get 59 minutes, and the borrowed 1 minute is nothing but 60 seconds. So 2 p.m. is nothing but 1 hour 59 minutes and 60 seconds. So subtract 35 seconds from 1 hour 59 minutes and 60 seconds. On subtraction, we get the time as 1 hour 59 minutes and 25 seconds. So the time shown by the faulty watch at 2 p.m. on the same day is 1 hour 59 minutes and 25 seconds. So the correct answer is option B, 1 hour 59 minutes and 25 seconds. A clock gains 15 minutes per day. It is set right at 12 noon. What time will it show at 4 a.m. the next day? Here you're given four options and you have to find out which of these options is the correct one. So it's given that the clock is set right at 12 noon and we're asked to find the time the faulty clock will show at 4 a.m. the next day. So first we have to find the duration from 12 noon to 4 a.m. Now from 12 noon to 12 a.m. it is 12 hours. From 12 a.m. to 4 a.m. it is 4 hours. So total time is 16 hours. Now it's given that the clock gains 15 minutes per day. Now one day has 24 hours. So in 24 hours the clock gains 15 minutes, which means in 16 hours the clock gains 15 multiplied by 16 divided by 24, which is nothing but 10 minutes. Now since the clock is gaining time, we have to add the 10 minutes to 4 a.m. to get the time shown by the faulty clock at 4 a.m. So the time shown by the faulty clock at 4 a.m. the next day would be 4 plus 10 minutes, which is 4:10 a.m. So the correct answer is option A, 4:10 a.m. A clock is at present showing 7 hours 40 minutes 6 seconds. Assuming that it loses 4 seconds in every hour, what time will it show after exactly 6.5 hours? Here you are given four options and you have to find out which of these options is the correct one. So here you have to find out the time shown by the faulty clock after exactly 6.5 hours. Now it's given that the clock loses 4 seconds every hour. So time lost in 6.5 hours would be 6.5 multiplied by 4 seconds. Now 2 multiplied by 6 is 12. 12 plus 1 is 13. So 6.5 can be written as 13 by 2. So 13 by 2 multiplied by 4 seconds is 26 seconds. So the clock loses 26 seconds in 6.5 hours. Now it's given that the present time is 7 hours 40 minutes 6 seconds. So correct time after 6.5 hours would be 7 hours 40 minutes 6 seconds plus 6 hours 30 minutes. Now you can write 6 seconds as it is. Now 40 minutes plus 30 minutes is 70 minutes. 70 minutes is nothing but 1 hour 10 minutes. So write 10 minutes as it is and carry over the 1 hour. So 1 hour plus 7 hours is 8 hours. 8 hours plus 6 hours is 14 hours. So correct time after 6.5 hours is 14 hours 10 minutes 6 seconds. Now we know that the clock loses 26 seconds in 6.5 hours. Since it is losing time, we have to subtract 26 seconds from the correct time after 6.5 hours. So the time shown by the faulty clock after 6.5 hours would be 14 hours, 10 minutes, 6 seconds minus 26 seconds. Now you cannot subtract 26 seconds from 6 seconds. So borrow 1 minute from the 10 minutes. So now 10 minutes becomes 90 minutes and the borrowed 1 minute is nothing but 60 seconds. So 60 seconds plus 6 seconds is 66 seconds. 66 seconds minus 26 seconds is 40 seconds. Write 14 hours as it is. So the time shown by the faulty clock after 6.5 hours is 14 hours, 9 minutes and 40 seconds. So the correct answer is option B, 14 hours, 9 minutes, 40 seconds. A clock which gains 5 seconds in 3 minutes was set right at 7 a.m. In the afternoon of the same day, when the clock indicated quarter past 4 o'clock, what will be the true time? Here you're given four options and you have to find out which of these options is the correct one. So here it's given that the clock was set right at 7 a.m. and you are asked to find the true time when the clock indicated quarter past 4 o'clock in the afternoon of the same day. Now quarter past 4 o'clock in the afternoon is nothing but 4:15 p.m. So time from 7 a.m. to 4:15 p.m. is 9 hours 15 minutes. On converting 15 minutes to hours, we get 9 15 by 60 hours, which on simplification gives us 9 1 by 4 hours. Now 4 multiplied by 9 is 36 plus 1 is 37. So 9 1 by 4 hours is nothing but 37 by 4 hours. Now it's also given that the clock gains 5 seconds in 3 minutes. So here, if the correct time is 3 minutes, then since the clock gains 5 seconds in 3 minutes, the to get the faulty time, we have to add 5 seconds to 3 minutes. So the faulty time would be 3 minutes 5 seconds. So when the correct time is 3 minutes, the faulty time is 3 minutes 5 seconds. Now let's equate the faulty time and the correct time. So 3 minutes 5 seconds of the faulty clock is equal to 3 minutes of the correct clock. Take a note of this important step where you're equating the faulty time with the correct time. Now, whenever you are solving problems where you have to find the true time, you always have to equate the faulty time with the correct time and then proceed. So 3 minutes 5 seconds of the faulty clock is equal to 3 minutes of the correct clock. Now convert 3 minutes 5 seconds to hours. Also convert 3 minutes to hours. So 3 minutes 5 seconds on conversion to hours would give us 3 by 60 plus 5 by 3600 hours, which on simplification gives us 37 by 720 hours. Now when you convert 3 minutes to hours, we get 3 by 60 hours, which on simplification gives us 1 by 20 hours. So 37 by 720 hours of the faulty clock is equal to 1 by 20 hours of the correct clock. So this means 37 by 4 hours of the faulty clock is equal to 720 multiplied by 1 multiplied by 37 divided by 37 multiplied by 20 multiplied by 4 hours of the correct clock. Now 37 divided by 4 is 9 1 by 4 hours, which is nothing but 9 hours 15 minutes. On solving this, we get 9 hours. So 9 hours 15 minutes of the faulty clock is equal to 9 hours of the correct clock. Now as you can see here, the correct time is 15 minutes behind the faulty time. So when the faulty clock shows 4:15 p.m., the correct time is actually 4 p.m. So the correct answer is option B, 4 p.m. A clock is set right at 5 a.m. The clock loses 16 minutes in 24 hours. What will be the right time when the clock indicates 3 p.m. on the 8th day? Here you are given 4 options and you have to find out which of these options is the correct one. So here it's given that a clock is set right at 5 a.m. and we have to find the right time when the clock indicates 3 p.m. on the 8th day. So first let's find out the duration from 5 a.m. on the first day to 3 p.m. on the 8th day. Now 5 a.m. on the first day to 5 a.m. on the 8th day is 7 days. Now since each day has 24 hours, this means 24 multiplied by 7, which is 168 hours. Now 5 a.m. to 3 p.m. on 8th day is 10 hours. So total time is 178 hours. Now it's given that the clock loses 16 minutes in 24 hours. So since the clock is losing time, you have to subtract 16 minutes from 24 hours. Now you can write 24 hours as 23 hours 60 minutes. Now 23 hours 60 minutes minus 16 minutes is 23 hours 44 minutes. Now 23 hours 44 minutes is the faulty time. Now let's equate the faulty time with the correct time. So 23 hours 44 minutes of the faulty clock is equal to 24 hours of the correct clock. Now let's convert this 45 minutes to hours. So we have 23 plus 44 by 60 hours, which on simplification gives us 356 divided by 15 hours. Now 356 divided by 15 hours of the faulty clock is equal to 24 hours of the correct clock. So 178 hours of the faulty clock would be equal to 15 multiplied by 24 multiplied by 178 divided by 356 hours of the correct clock. Now when you simplify this fraction, you get 180 hours, which means 178 hours of the faulty clock is equal to 180 hours of the correct clock. As you can see here, clearly the correct time is 2 hours ahead of the faulty time. So when the faulty clock shows 3 p.m. on the 8th day, the correct time is actually 5 p.m. So the correct answer is option B, 5 p.m. Imagine that your watch was correct at noon, but then it began to lose 30 minutes each hour. It now shows 4 p.m., but it stopped 5 hours ago. What is the correct time now? Here you are given 4 options and you have to find out which of these options is the correct one. Now it's given that the watch was correct at noon, and then the watch loses 30 minutes each hour. So from 12 p.m. to 1 p.m. the watch loses 30 minutes. So the time is 12:30 p.m. So when the faulty watch shows the time as 12:30 p.m., the real time is actually 1 p.m. Now from 12:30 p.m. to 1:30 p.m., the faulty watch loses 30 minutes. The time is 1 p.m. So when the faulty watch shows the time as 1 p.m., the correct time is actually 1:30 p.m. From 1 p.m. to 2 p.m., the watch loses 30 minutes. The time is 1:30 p.m. So when the faulty watch shows the time as 1:30 p.m., the correct time is actually 2 p.m. Now this continues. So from 12 noon, it takes 8 hours to show 4 p.m. So when the faulty watch shows the time as 4 p.m., it is the correct time is actually 8 p.m. Now it's given that the faulty watch stopped when it was showing the time 4 p.m. This means the faulty watch stopped at 4 p.m., which means that the actual time when the watch stopped is 8 p.m. Now it's given that the watch stopped 5 hours ago. Now since the watch stopped 5 hours ago, the correct time is 5 hours ahead of 8 p.m., which is 1 a.m. So the correct answer is option C, 1 a.m. A watch which gains uniformly is 2 minutes slow at noon on Monday and is 4 minutes 48 seconds fast at 2 p.m. on the following Monday. At what time was it correct? So here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find out at what time the faulty clock will show the correct time. Now it's given that the watch is 2 minutes slow at noon on Monday and it is 4 minutes 48 seconds fast at 2 p.m. on the following Monday. So first we have to find the duration from Monday 12 p.m. to the following Monday 2 p.m. Now this duration will be 7 days 2 hours. Now we know that one day is 24 hours. So 7 days would be 7 multiplied by 24 hours. So 7 days, 2 hours is nothing but 170 hours. Now it's given that Monday 12 p.m. the watch is 2 minutes slow. This means the watch is 2 minutes less than the correct time. So from Monday 12 p.m. if the watch gains 2 minutes, then it will show the correct time. And from the correct time, the watch gains 4 minutes 48 seconds. And next Monday 2 p.m. the watch is 4 minutes 48 seconds fast. So the watch gains 2 minutes plus 4 minutes 48 seconds from Monday 12 p.m. to uh, next Monday 2 p.m. So the watch gains 2 minutes plus 4 minutes 48 seconds. Now let's convert this 48 seconds to minutes. So we have 2 plus 4 48 by 60 minutes. On solving this, we get 34 by 5 minutes. So from Monday noon to next Monday 2 p.m. the duration is 170 hours, and during that duration the watch has gained 34 by 5 minutes. So the watch gains 34 by 5 minutes in 170 hours. Now we are asked to find out at what time the faulty watch will show the correct time. Now we know that Monday 12 p.m. the watch is 2 minutes slow, which means it is 2 minutes less than the correct time. So from Monday 12 p.m. if the watch gains 2 minutes, then it will show the correct time. So first we have to find out how much time is required by the watch to gain those 2 minutes from Monday 12 p.m. so that it can show the correct time. Now we know that the watch gains 34 by 5 minutes in 170 hours. So it will gain 2 minutes in 5 multiplied by 170 multiplied by 2 divided by 34 hours, which is nothing but 50 hours. Now 50 hours is nothing but 2 days, 2 hours. So from Monday 2 p.m. the watch requires 2 days, 2 hours to gain 2 minutes to show the correct time. So the watch is correct 2 days, 2 hours after 12 p.m. on Monday. That is, it will be correct at 2 p.m. on Wednesday. So the faulty watch will show the correct time at 2 p.m. on Wednesday. So the correct answer is option B, 2 p.m. on Wednesday. How much does a clock lose or gain per day if its hands coincide every 62 minutes? Here you are given 4 options and you have to find out which of these options is the correct one. Now we know that 55 minutes are gained in 60 minutes, which means 60 minutes are gained in 60 multiplied by 60 divided by 55, which is nothing but 65 5 by 11 minutes. This means both the hands of the clock will coincide every 65 5 by 11 minutes. But it's given that the hands of the clock coincide every 62 minutes. Now since it's given that the two hands coincide in time less than 65 5 by 11 minutes, it means the clock is fast and it is gaining time. Now we know that the hands of the clock coincides every 65 5 by 11 minutes, but it's given that the hands of the clock coincide every 62 minutes. So the time gained by the clock in 62 minutes is 65 5 by 11 minus 62 minutes. On solving this, we get 38 by 11 minutes. Now here we are asked to find out how much does a clock lose or gain per day. So we have to find the time gained by the clock in one day. Now one day is 24 hours and 24 hours is nothing but 24 multiplied by 60 minutes. Now we know that time gained by the clock in 62 minutes is 38 by 11 minutes, which means time gained by the clock in one day, that is 24 multiplied by 60 minutes, would be 38 multiplied by 24 multiplied by 60 divided by 62 multiplied by 11. On solving this, we get 80 by 341 minutes. So the clock gains 80 by 341 minutes per day. So the correct answer is option D, 80 by 341 minutes gain. The minute hand of a clock overtakes the hour hand at intervals of 76 minutes of the correct time. How much does a clock gain or lose in a day? Here you are given four options and you have to find out which of these options is the correct one. Now we know that 55 minutes are gained in 60 minutes, which means 60 minutes are gained in 60 multiplied by 60 divided by 55, which on solving we get 65 5 by 11 minutes. This means both the hands of the clock will coincide every 65 5 by 11 minutes. But it's given that the hands of the clock coincide every 76 minutes. Now, since the two hands coincide in time more than 65 5 by 11 minutes, it means the clock is slow. That is, the clock is losing time. Now we know that both the hands of the clock will coincide every 65 5 by 11 minutes. But it's given that the hands of the clock coincide every 76 minutes. So the time lost by the clock in 76 minutes is 76 minus 65 5 by 11 minutes. On solving this, we get 116 by 11 minutes. So the time lost by the clock in 76 minutes is 116 by 11 minutes. Now here we are asked to find out how much does the clock gain or lose in a day. Now we know that one day is 24 hours and 24 hours is nothing but 24 multiplied by 60 minutes. So we know that the time lost by the clock in 76 minutes is 116 by 11 minutes, which means the time lost by the clock in one day, that is 24 multiplied by 60 minutes, is 116 multiplied by 24 multiplied by 60 divided by 76 multiplied by 11. On solving this, we get 199 169 by 209 minutes. So the clock loses 199, 169 by 209 minutes in a day. So the correct answer is option C, 199, 169 by 209 minutes loss. Viewers, please go through this video till you have understood the concept. Practice more such problems to increase your speed and also to understand the concept clearly. Please do watch a video on clock, mirror image based time, solved problems. If you have liked this video, please like, subscribe and share this video. Thank you.